Every single thing moving, same part. These legs, same part. These front wheels steering, same part. A hobby servo. And here's the kicker. The one I'll build with all series, this little black guy, costs just a few dollars. And if the ESP32 from last episode is the brain, the servo is the muscle. It's hands down the easiest way to make a robot actually move. Welcome back to minirobo. One off-the-shelf part per episode, one step closer to your own robot. Last time we did the brain. Today we make it move. By the end, you'll know what a servo is, the bare minimum to drive one, the genuinely cool story of where it came from, and the stuff I really wish I knew before I stripped my first set of gears. Let's go. So, this is the star of the show, a hobby servo. And the one I build with is the MG90S, a little 9-gram black servo with metal gears inside. It's about the size of your thumb, has 3 wires coming out, and ends in a little plastic arm called a horn. What makes a servo special? Inside that case is a little motor, a set of gears to give it muscle, and a tiny control circuit. You don't tell a servo spin, you tell it an angle. Go to 90 degrees. And it goes there and holds it, even if something pushes against it. That's the whole trick. Precise, repeatable position. Perfect for joints, legs, grippers, and steering. Bare minimum to use one. First, the 3 wires. Brown or black is ground, red is power, and orange or yellow is the signal wire. That order is almost universal, but glance at the datasheet because a wrong way plug can fry it. Second, and this matters, a servo wants about 5 volts to be happy, and it pulls real current when it moves. Do not try to power it from the ESP32's 3.3 volt pin. Give it its own 5 volt supply, and connect that supply's ground to the ESP32's ground so they agree. The signal wire goes to a GPIO pin. Third, how do you actually command the angle? The servo listens for a PWM signal, a precise timed pulse, about 50 times a second. The width of that pulse is the angle. Sounds fiddly, but you never do the math. There's a servo library on the ESP32. It's called ESP32 Servo. One line in your platform.io ini file, and platform.io pulls it in. Then you literally write servo.write90, and it goes to 90 degrees. That's it. 3 wires, its own 5 volts, 1 signal pin, servo.write, plug it in, sweep it back and forth, and you've just animated your first robot joint. See this old timer? Inside that wing, for decades before robots existed as a hobby, lived this exact part. Servos didn't start in robotics. They started in toys. Well, expensive toys. To steer something you're not holding, you need something that takes a radio command and moves a control surface to an exact position. Flaps up this much. Rudder over this much. That's the servo's whole job, and the RC industry spent decades refining it. Small, reliable, position-controlled muscle in a sealed plastic box. Over time, the RC world standardized almost everything about them. The connector, the wire colors, that 50 hertz pulse signal, even the physical sizes. And that standardization is the gift. Because when hobby robotics took off, builders looked over at this mature, dirt cheap, mass-produced part and went, wait, that's a perfect robot joint. Then manufacturing in China drove micro servos like the MG90S down to just a few bucks each. And that was the tipping point. Suddenly, a walking robot with 12 joints wasn't a lab project. It was $40 of servos in a weekend. The 3D printing boom hit at the same time. So people could print custom brackets and horns. Servo plus printed brackets became the Lego brick of hobby robotics. A part that cost less than a coffee, carrying decades of radio control engineering handed to us almost for free. What I wish I knew. Okay, hard-won lessons. 1, the big one. And I'd rather show you than warn you. Watch the serial monitor. Every time the servo moves, it yanks a big gulp of current. The voltage dips, and the brain faints mid-thought. Over and over. Same code. The only change is the servo getting its own 5-volt supply with grounds shared. Do that from day one, and the random reboots never happen to you. 2, about those gears. And there's an easy way to tell these servos apart at a glance. The Metal Gear MG90S I keep showing you is black. And the cheaper one, the blue SG90, usually runs $1 or so less. That blue one is so tempting in the multi-pack, but resist it. The blue SG90 uses plastic gears, and plastic gears strip. The first time a joint holds weight, slams a wall, or your code fights a jammed limb, you'll hear a horrible grinding, and that servo's dead. Saving a few pennies on plastic gears is never worth it in the long run. The black MG90S's metal gears just shrug off the abuse that turns an SG90 into a paperweight. So when you're shopping, black metal gears every time. Buy them once and stop replacing servos. 3, a cheap servo's range is approximate. You command 0 to 180, but a given unit might really do like 10 to 170. And 2 identical servos won't match exactly. Always test the real range and don't drive it hard into the ends. Jamming against the stop overheats the motor. Find the safe limits and stay inside them in code. 4, before you screw the horn on, command the servo to its center position in code. Then attach the horn pointing where you want. If you force the horn around by hand to line it up, you're cranking the gears backward and you can strip them, or your range ends up lopsided. Center first, then mount. 5, if your servo buzzes and twitches when it should sit still, it's almost never the code. It's usually weak or noisy power supply or a long signal wire picking up interference. Beef up the wire, keep the signal wire short, and that nervous little jitter calms right down. So that's the hobby servo. A few dollars of decades-old RC engineering that turns your robot's brain into actual motion. Three wires, its own 5 volts, 1 servo.right, and you're moving. This week's 60-second challenge. Find the servo's real range. Walk it toward 0 and toward 180 in code, gently, and find where yours actually stops. Post your 2 numbers in the comments. I want to see how wild the spread is across identical servos. Mine does about 8 to 174. The 3 wires, the power rule, and all 5 lessons fit on 1 cheat sheet card free on the episodes page, minirobo.io. But servos are for joints. What about wheels that just need to roll fast and free? For that, we need to drive a different kind of motor. And we can't do it from a pin alone. Next time on MiniRobo, the motor driver, the little chip that lets your tiny brain command big, hungry motors. Subscribe so you don't miss it. All the parts are linked below, and come show off your first moving joint in the comments. See you next time. Let's build something. Is the cameraman ready?
Go!